Hi there, my name is Kira, and today I'm going to be working through a mathematics past paper, specifically the November 2021 mathematics past paper from the DBE curriculum. I'm going to be focusing on question 1, which centers around quadratic equations. And I'm going to use this paper as a guide to work through each type of quadratic equation that you will likely face in your final examination. So I'm going to dive right in and begin with question 1.1. Okay. Question 1.1 is a traditional quadratic equation. We see that we have a trinomial, which is likely factorizable, which is equal to 0. And we don't have any roots or x's in the denominator. So at this point, we won't need to perform any tricks to simplify this equation. This equation is ready to be factorized and solved. When I work with quadratic equations, I always like to remember the following 3 steps. The first step is what I call the rule of 0. Okay. You need to ensure that the right-hand side of your equation is equal to 0. In this case, we see that we have that. The second step is to factorize. And the final step is to split and solve. Okay. Since my first criteria has already been met, I am ready to factorize this expression. This is a trinomial, so we will use the trinomial factorization method. Everyone does this method differently, and I'm not going to focus on that today. So I know that if I factorize this, I must have an x, 2 x's at the beginning of each bracket. Then I know that my constant is negative 24. Because the constant is negative, I know I must have a minus in one bracket and a plus in the other bracket. I then go look at the factors of 24 and choose a combination that is going to result in the constant being equal to negative 2. In this case, I see that negative 6 plus 4 is going to give me the required middle term. So negative 6 plus 4. You can now see that I've completed the second step, which is to factorize. Now I'm ready to do the third step, which I call splitting and solving. So I take each bracket and set each bracket equal to 0. X minus 6 equal to 0, or x plus 4 equal to 0. So I've now done the split step. Now I need to solve. I need to solve for x. I need to isolate x. And I'm going to do this by taking the negative 6 over here. When I take the negative 6 over the equal sign, it becomes positive 6. And over here, I take the positive 4 over and it becomes negative 4. And now I have 2 solutions for x. The nice thing about equations is that you can always check your answer to check if you've done the right thing. And you will see if you substitute x is equal to 6 into this equation, you will get 6 squared, which is 36, minus 2 times 6, which is 12, minus 24. And that will equal 0. And my equation says that x squared minus 2x minus 24 must equal 0. And when x is equal to 6, we see that the expression does equal 0. So we've done the right thing. The same thing will happen if you substitute in x is equal to minus 4. Now, you may be wondering, why do we approach equations in this method? Okay, like, why do we set the right-hand side equal to 0? And why do we factorize? Okay, and then split our solutions. So the reason why we set the right-hand side equal to 0 or move everything over so that the right-hand side is equal to 0 and then factorize is simply for convenience. because if it's equal to 0 and then I factorize, I can clearly see that either the first factor must equal 0, because 0 multiplied by anything will give me 0, which means that my equation holds true. Or the second bracket must be equal to 0, i.e. x must be equal to -4, because anything multiplied by 0 is equal to 0. Or both brackets must equal to 0, i.e. x must equal 6, or x must equal -4, and x must equal -4. This will give us our required result of 0. Okay. So that is why we do it in this manner. It's simply because it's convenient, and it's very easy to solve equations that are equal to 0. Okay. Now we move on to our second question. Immediately, I know that I need to use the quadratic formula in this question. How did I know that? Well, it's because next to the question they said correct to 2 decimal places. They often say this because the quadratic equation does not give us a whole number as an answer. And the reason when we need to apply the quadratic equation, we could apply the quadratic equation to any quadratic, the quadratic formula. Sorry, I meant to say that we can apply the quadratic formula to any quadratic equation we encounter. However, when we need to use the quadratic formula is when we cannot factorize the expression in the quadratic equation, the expression on the left-hand side. And because we cannot factorize it, we will always get answers that are not whole numbers. So that is why they said correct to 2 decimal places here. And if you see this, it's immediately a hint that you should do the quadratic formula. However, if you are trying to solve a quadratic equation with the traditional method that we've just done, where you try and factorize each side, and you cannot factorize easily, then use the quadratic formula. The quadratic formula is given on the formula sheet of the provided formula sheet for the mathematics final examinations. However, in your tests at school, your teacher might not always give you the quadratic formula. Therefore, it is worth remembering the quadratic formula. Okay? The quadratic formula is given by x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, what are these b's and a's and c's that I'm talking about? A refers to the coefficient of the x squared term. B refers to the coefficient of the x term, and C refers to the constant. So in our case here, A is going to be equal to 2, B is going to be equal to -3, and C will also be equal to -3. Okay. Before we dive into the quadratic equation, let's investigate whether I was right and whether or not this equation is actually factorizable. I've claimed that it's not factorizable. Let's investigate my claim. Okay, so we try and factorize the left-hand side. So I must have a 2x in one bracket and an x in the other bracket. Now my constant is 3. So the factors of 3, it's a prime number. So 3 and 1 are my only factors, okay? The constant is negative, which means we must have a plus and a minus combination of 3 and 1, which give us our middle term. Now, -3 plus 1 gives us -2. Our middle term is not equal to -2x. So we cannot use this combination. Or I could say positive 3 minus 1, which gives me positive 2. And my middle term is not equal to positive 2. So do you see no combinations of the factors of the constant give me the required middle term, which means that it's not factorizable. So we need to use the quadratic formula. All right. So when I do the quadratic formula, I like to do it in a very methodical way. I really want to ensure that I do apply this formula correctly. Okay. So what I like to do is on the side, I like to say what A, B, and C are equal to. Okay. A is equal to 2, B is equal to minus 3, and C is equal to minus 3. Okay. So now we substitute all these quantities into the quadratic formula. Okay. Negative B, so it's going to be negative 3. Whenever we use a formula and do substitution, please use brackets. This avoids possible sign errors. Okay, B squared, so negative 3 squared minus 4 times A, which is 2, times negative 3. All right. All over 2 times A, which is 2. Okay. 2 times 2. Now, what you need to do is substitute this formula into your calculator. Okay. So you will notice on your calculator that you do not have a plus or minus sign. You need to, what we need to realize is that in quadratic equations, we usually have two solutions. 90% of the time, you'll have two solutions. That is why we have a plus and a minus. When we say negative b plus the square root of b squared, etc., that gives us solution number 1. And when we say negative b minus the square root of b squared minus 4ac, etc., that gives us the other solution. So you want to type this into your calculator and first consider the case where we use a plus. I am going to get us a calculator. Let's wait a minute for the calculator app to. All right, so this is a little bit difficult to navigate. Okay, so we see that we've got a fraction. So immediately I'm going to, so we had, struggling to see now. Sorry, this thing is very difficult to use. I'm just going to move the scientific calculator app. How on earth do I do that? Sorry about the technical issue. I've figured out how to use the calculator. So I'm going to type in my equation, which is negative 3 plus the square root of negative 3 squared minus 4 multiplied by 2 multiplied by negative 3 over 2 multiplied by 2. And I get an answer of 2.19 if I round off. Sorry if that calculator was slightly unclear because I was a bit zoomed out. 2.19. Now we go and consider the case where we say minus the root. Okay, in this case, we get negative 0.69. So that is our answer. And now you can see we use the quadratic equation to find the two solutions to our problem. Okay. So at this point, we have covered two types of equations. The traditional quadratic equation, where we set the right-hand side equal to 0, factorize the expression on the left-hand side, split the brackets, set each bracket equal to 0, and solve for x. Then we saw a case where we couldn't factorize the equation. We couldn't factorize the expression on the left-hand side, so we had to use the quadratic formula. And we saw it was as easy as remembering the quadratic formula, identifying what A, B, and C is, correctly substituting, and placing it in our calculators. Once you've practiced using the quadratic formula, it will become very easy. All right. Now, this is our third type of quadratic equation. We can see that we have a square root on the left-hand side. And at first glance, this doesn't even look like a quadratic equation because there's no x to the power of 2 anywhere. There's no x squared anywhere. How do I know that this is a quadratic equation? Well, the magic will still soon be revealed. Okay. When we solve any type of equation, we know that we always apply the opposite operation to isolate x. It's always our goal to get x alone, and what we will do is perform the opposite operation to x to eventually isolate it. What do I mean by that? Well, let's consider an easy example, rather a simple one. Okay, 3x is equal to 1. I want to get x alone, so I need to get rid of this x multiplied by 3. The opposite of multiply is divide. So I will divide both sides by 3. Then these 3's cancel, and I get that x is equal to a third. So I know the opposite of multiply is divide, and vice versa. And we do the same thing with addition and subtraction. Now in this equation, once again, I want to isolate x, but I have a bit of trouble because x is under the square root. So I need to get rid of the square root in order to isolate x. To get rid of the square root, I need to do the opposite of a square root, which is squaring. So what I'm going to do is I'm going to square the square root. What I do to the one side, I have to do to the other side. You have to square the entire right-hand side. You cannot say that this is equal to the first term squared minus the second term squared. You will get the wrong answer. You need to square the entire right-hand side. Another thing worth noting is before you square a square root in an equation, you need to make sure that the square root is isolated on one side of the equal sign, and all other terms that are not involved in a root are on the other side of the equal sign before you square. Otherwise, things will start to go wrong. Okay, so we just need to keep that in mind. Now, on the left-hand side, the square is just going to cancel out that square root, and I will get x plus 28 because the square just cancels out the square root. Then on this side, I need to square, but I need to FOIL because it's a bracket squared. So to avoid making any computational errors, I'm going to write this out like this. At the end of the day, it's a test or an examination, so you want to make sure that you don't make any silly maths mistakes. Okay, now I'm going to go and FOIL the right-hand side. Okay, so I need to multiply the first two terms together, and that is going to give me an answer of 4. Then I need to multiply 2 the first term by the second term in the second bracket, and I'm going to get minus 2x. Then I continue, second term in first bracket multiplied by first term in second bracket. So get minus 2x again. And then finally, the second terms multiplied by each other. Negative x multiplied by negative x gives me positive plus x squared. Now, you can see that this is actually a quadratic equation because an x squared term has revealed itself. Okay, now I see I've got a more traditional type of quadratic equations. I've just got expressions involving x squared, x, and constants. Yes, this expression is not simplified, and it's not in the classical trinomial equal to 0 form. So let's get it in that form because we know how to deal with trinomials equal to 0. Okay, so first thing I'm going to do is I want to bring all the terms over to one side. Okay, so I'm going to bring it all over. I'm going to take all of these terms here over to that side. Okay, so I'm going to say 0 is equal to, I'm going to start by writing x squared. Okay, because that's just more orderly. Okay, on this side, I had minus 2x minus 2x. I'm actually just going to simplify those two immediately. I get minus 4x. So I've included x squared, this minus 2x minus 2x. I've got a plus 4. I often like to tick things off when I'm doing complicated addition, just so I don't forget anything behind. Now I need to take this 28 over. It becomes negative 28. Then I need to take the x over, and it becomes minus x. Now I need to look for like terms and simplify. Okay. So x squared does not have any like terms. Okay. But I have an expression with an x here, minus 4x and minus x. When I add those together, I get minus 5x. Then I see I have two constant terms. So actually, first, let me do the ticking off thing. I've got my x squared. I've got my minus 4x. I've got my minus x. Now I need to do plus 4 minus 28. Well, that simplifies to minus 24. Okay. So now I have a trinomial equal to 0. I have satisfied the first step of solving a quadratic equation, which is the rule of 0. Okay, my next step is to factorize the trinomial. Okay, so I'm actually going to write the 0 on the right-hand side because that's what we're used to. Okay, so we just write it on the, still means the same thing. Okay, now I know that when I factorize a trinomial, I need to have two brackets with an x as the first term in each. Okay, because x times x will give me x squared. Okay, 24, let me think of those factors once again. I know it's 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Okay, I've got a negative 24, so I know I must have a minus in one bracket and a plus in another bracket. Now, what combination is going to give me minus 5? I can see clearly that 1 and 24. I'm going to get either minus 23 or positive 23. 2 and 12 is minus 10 or positive 10. Okay. 3 and 8, aha. Minus 8 plus 3 will give me minus 5. So let me pop that in. And now I have factorized the expression. So my second step is done. My final step is to split and solve. So I set each bracket equal to 0, x minus 8 equals 0. And I always need to say or to separate my solutions. X plus 3 is equal to 0. Okay. Now I've split. Now I must solve. Okay, to get x alone, I need to take minus 8 to the other side, so it becomes positive 8, and I get that x is equal to 8. And on the other side, x is equal to minus 3. And now we are done. You can go back and substitute these x values into the original equation, and you should get the right answer. Okay, I want you to pause the video here and try substituting in our x values and seeing if you get the right answer. You need to have the left-hand side equal to the right-hand side to know you've done the right thing. If you are not getting that the left-hand side is equal to the right-hand side, then you need to try again. Okay, so the next question is x plus 3 over 2x is equal to 1. This question is not in the past paper. I made up this question because I wanted to go through one of the final types of quadratic equations. This is the case where there is an x in the denominator. Okay. We cannot go through our normal steps. Well, first of all, we don't even have a trinomial. So we can't do immediately we see that this is not like our normal kind of quadratic equation. And we don't really know what to do when we have an x in the denominator. But remember, our goal of solving for x, solving any kind of equation, so we always want to get x or whatever variable. We always want to get that variable alone. Okay? I can't work with an x expression in the denominator. So how do I get something out of the denominator? Well, when something is in the denominator, it means that the number in the numerator is being divided by the number in the denominator. So to get 2x out of the denominator, we need to multiply by 2x. Okay? So how I'm going to write this is I'm going to say 2x. What I do to the one side, I must do to the other side. Okay. I can see immediately this is like a 2x over 1. Okay, because it's not a fraction. Okay. These terms will cancel and x will be out of the denominator. Okay. So actually, I can see that this question, I should have made this equal to x. Okay, sorry. I'm just quickly changing the question. Okay, so we're not going to end up with a quadratic equation. So let's change this question quickly. No, edit this. Formula. Okay. Okay, now we've successfully changed the equation. So once again, to get the 2x out of the denominator, I'm going to multiply by 2x. And what I do to the one side, I must do to the other side. Okay. Now, these 2x's are going to cancel. And it will be out of the denominator. So my new expression will read x plus 3 is equal to, now x multiplied by 2x is equal to 2x squared. Do you see that a quadratic equation has now revealed itself? My first step of solving a quadratic equation is the rule of 0. I must have one side of the equation equal to 0. So let me bring these terms over. Okay. Immediately, I see that we have 2x squared minus x plus 3 is equal to 0. Okay. Now, this expression is not factorizable, okay? Because to get 2x squared as the first term, I must have 2x in the first bracket and x as the first term in the second bracket equal to 0. I have, oh, sorry, this is actually supposed to be -3. Excuse my mistake. Maybe it'll be factorizable now, okay? In one of my brackets, because I've got -3 over there, I need to have minus in one of the brackets and plus in another one of the brackets. I also know that the factors of 3 are 3 and 1. So I now go through a process of trial and error. I could have -3 here and +1 over here. But if I FOIL this expression out, I will get the first term being 2x squared. Then I will get -6x plus x -3. We can see immediately that my middle term is does not become -x. So let me try and swap these around. Let's try and say -1 over there and +3 over there. Okay, so 2x multiplied by -1 will give me -2x plus 3x, which will give me a middle term of 1x. I can see I'm very close to factorizing this expression. So let me go swap the signs around, okay? Now I will get an expression of a middle term of plus 2x minus 3x, and that will become -x, which I need. Now that I've factorized this rather tricky trinomial expression, I'm going to split and solve. So I'm going to set the first bracket equal to 0, and then the second bracket, so I'm going to say or the second bracket's equal to 0. Okay. Now I need to solve for x in each equation. So I'm going to take this -3 over. So I've got 2x is equal to 3. Then I divide by 2, and I get that x is equal to 3 over 2. Okay. On the other side, I simply need to take the positive 1 over, and I get that x is equal to -1. And that is the expression, and that is the equation solved. Let's take stock of what we have done so far before we move on to the next question, which is an inequality. Okay, we have covered what I call the traditional quadratic equation, where we had a trinomial equal to 0. And that's where we first introduced the idea of making sure that the right-hand side is equal to 0, factorizing and splitting and solving. We started to see that having an equation in this form, where it's a trinomial equal to 0, was kind of our goal. Because if we have a trinomial equal to 0, then we can solve it using these 3 steps. Okay. In the second type of equation, it was very clear that we were able to do step 1, get a trinomial equal to 0, but we weren't able to do step 2, which was factorize. So then we needed to use the quadratic equation. In question 1.1.4, we saw that we did not have a trinomial equal to 0. And we had a root, and we weren't sure what to do. So we realized that our biggest problem here, the thorn in our side, so to speak, was the square root. So to be able to do this equation, we need to get rid of the square root first. And how do we get rid of a square root? Well, we do the opposite, which is square the square root. And before you square a square root in an equation, you need to make sure that all other terms are on the other side of the equal sign. And when you square the square root, you need to square the whole of the other side and FOIL the other side. Otherwise, you will make mistakes. Then, once we had done the squaring of the square root and a bit of simplification, a normal or familiar looking trinomial, which is over here, equal to 0 revealed itself. And then we could use our normal method of solving an equation. We have a trinomial 0, we factorize, we split the brackets off, and we solve. So, okay, then we had encountered our last type, which was when we have x in the denominator, okay? We do not like having x in the denominator. It makes it difficult to isolate x. So we multiply out. The left-hand side we multiply by the denominator, and the right-hand side we multiply by the denominator to get x out of the denominator. And then a trinomial equal to 0 will reveal itself. And then we can go through our normal steps of rule of 0 is the right-hand side equal to 0, factorizing, and setting each bracket equal to 0. Okay. So that is how we tackle each different type of equation. You need to practice these, and you will start to see the patterns that I spoke about today. That often we might need to do a few tricks, but at the end of the day, what we are doing is we have a trinomial, which we equal to 0, which we factorize, set each bracket equal to 0, and solve for x. Once you keep that pattern in mind and know that those are the steps you need to go through, solving equations will become second nature to you. Now, we get to the problem of inequalities, or the concept of inequalities. People explain inequalities in a number of different ways, but I think I found one method that always works and students always respond very well to. So this might be a method that you are completely unaware of and if you've never seen before. So let's tackle this question with an open mind, and you will see how my method works. Okay, so what I like to do with inequalities is I like to, at the beginning, treat it like a normal quadratic equation. So you see here, it sort of looks like our normal quadratic equation. We have an x squared term, a plus 5x, a minus 4. It's looking a lot like a trinomial, except the right-hand side is not equal to 0. So let's fix that. Okay, I'm going to bring the minus 4 over. So then that right-hand side will be 0. Okay, we still need to keep our inequality signs because even though we are thinking of it more like an equation, it is still an inequality. Now, if this was an equation, our next step would be to factorize. We are still going to do that. Okay, so if I factorize this expression, I need to have an x here and an x here. These terms will multiply together to give me the x squared. Then I need to consider the factors of 4. For our constant term is positive, which means we either have a negative term multiplied by a negative term or a positive term multiplied by a positive term. And the factors of 4 are 4 and 1 and 2 and 2. What combination is going to give us 5? Well, I can see immediately that 4 plus 1 is going to give me 5. So I should have plus 4 and plus 1 is going to give me 5. Okay. Furthermore, if this was a quadratic equation, we would now split each bracket and set it equal to 0 and solve for x. Once again, I'm going to do that, except I'm going to say see these. This means I'm showing the marker that I'm calculating the critical values. These are the values of x that will make the expression equal to 0. Okay, these are important. So my first one will be x plus 4 equal to 0. So don't forget to write the CVs thing. Otherwise, the marker might be confused. Okay. Then I'm going to solve. I'm going to get x is equal to minus 4 or x is equal to minus 1. Okay. Now, this is where there are differences between inequalities and equations. Now, you need to draw a number line. Okay. Practice drawing this number line because you will need to recreate it every time if you choose to use my method, which I strongly recommend you do. Okay. Now we need to put our critical values, these x values, on the number line. Which number comes first, 4 or negative 1? Negative 1 comes first. So I put negative 1 up there. And, oh, sorry, that's a negative 4. Sorry, so negative 4 comes first. And then negative 1. Okay. Now you need to put dots above each number. So you need to go back and look at your original inequality sign. Okay. If you have an inequality sign with an equal to part, so it has that extra line underneath, you need to do a closed dot. And if you have an inequality without that little line underneath, you have an open dot. Okay. What I've done here is I've put 2 open dots. So we know this is wrong. I must have closed dots. Okay, because it's less than or equal to. Okay. How I like to remember whether it's a closed dot or an open dot is like that this extra line here on the inequality fills in the dot. That's how I like to remember it. Now, next part. You need to remember this off by heart, and it's the same every time. To the left of the first number, we write plus. In the middle, we write minus, and on the other end, we write plus. So you must always remember plus, minus, plus. It never changes. Plus on the one side, minus in the middle, plus on the other side. Okay. Now, you need to look at your original question. Do you see that it says less than or equal to 0? Okay. Something that is less than 0, do you agree, is negative. So I will be in the negative section of my numbers. So I draw a line over the negative section connecting the dots. Okay. And if you have that line there in the middle, then you know that x is sandwiched, or it is between minus 4 and minus 1. Okay. Now, at first, this might seem a little bit strange, but don't worry, I'm going to go through it again. Okay. Let's consider the case where we had greater than or equal to 0. Okay. So I'm going to go and change the question. Greater than or equal to 0. Do you agree something that is greater than 0 is positive? So x is going to be in the positive section. And I denote this by drawing an arrow going to negative infinity and an arrow going to positive infinity. And the nice part about this method is now we need to write our x values. So I'm going to write x, and I'm going to copy the direction of the arrowhead. And I mustn't forget that it's including. And then I write the number that this arrow is near. So minus 4. And on this side, I can see that the arrow is in that direction. So x is greater than or equal to minus 1, the number associated there. Okay. So further your understanding of these inequalities, I am going to go back to some of our other equations and turn them into inequalities. So this one here, 2x squared minus x minus 3. I'm going to make this less than or equal to 0. Now, I've already solved these equations, so I know what the CVs are, okay? The critical values. It's x is equal to 3 over 2, and x is equal to minus 1. Okay, now I need to draw the number line. Okay, so I draw the number line. I need to think which critical value will come first, minus 1 or 3 over 2. Minus 1 is going to come first because it's smaller than 3 over 2. Okay, then I need to draw the dots. For interest's sake, I'm actually going to change this from equal to just less than. So from less than and equal to just less than. So now I need to do open dots above each number or critical value. And I always remember that it goes plus, minus, plus. And then I go back and look at my question. It's less than 0. So that's negative. So my x is in this negative sandwich, a section, which means it's sandwiched or in between these two values. And whenever I have the sandwich or in between case, I always go minus 1 greater than or equal to x greater than or equal to 3 over 2. There we go. So this is something that you need to practice. I'm going to write the steps down, and then I want you to go and find examples from past papers or maybe even in your textbooks. Or actually, I'm going to look for some examples and put them down for you. And I want you to practice this method. Okay, so let's create a little bit of space and write down steps. Okay, so step 1 was definitely the rule of zero thing. So all terms on one side of equal sign. Oh, that's a plus sign. Equal sign. Okay, the second step is to factorize, split, and then split and solve to find the critical values. Okay, the third step, not the second step, is to construct a number line. Okay, and then we need to remember the plus, minus, plus. Then check question. Is it one of the two? Is it greater than 0? Because that means positive. So draw in, let me move down so we can see what I'm writing. Draw in, sorry, I'm having a little bit of a technical difficulty. Draw in the arrows and copy direction of arrowheads when writing the answer. Okay. Then, or the second option is for when it's less than 0 or less than or equal to 0. Okay, kind of means the same thing. All it's really going to influence is the type of inequality sign used at the end, and you just need to make sure you use the right one. Okay, if it's less than or equal to 0, it means negative. So we do the sandwich. So it's going to be, I don't know, x1 less than or equal to x less than or equal to x2. So what I mean by that is that's going to be the general form, okay, where x1 and x2 are like critical value 1 and critical value 2. So if the first critical value was -3 and the second critical value was 4, I mean that we're going to write x in this kind of sandwiched way. I'm going to now pause and find some examples of inequality questions that you can go practice by yourself. Okay, so I found 2 examples for you to practice by yourself, and I've put the answers over there. So just pause quickly and take this down. I wanted to go through another inequalities question because I wanted to point out something really important. So I'm just waiting for the question to paste properly. Okay, so this inequality is in the form we like. It's a trinomial with 0 on one side. Okay, now to factorize this trinomial, it's pretty difficult to do with a negative in front of the x. And most of the time, negative in front of the x squared. And most of the time when you have a negative in front of the x squared, we'll divide out by -1, okay, to make it easier. But with inequalities, if you divide out by a negative, you have to change the direction of the inequality. So if I divide out by a negative, I'm going to get positive x squared plus 2x minus 8. And then I need to change the direction of the inequality sign. Okay. Then my next step would be to find the CVs by factorizing the critical values. Okay. And how I would I'm just going to do the factorization quickly. And this is what you get. So your critical values, if you split each bracket and set it equal to 0 and solve for x, you will get the following critical values. X is equal to -4. X is equal to 2. Now we set up our number line with -4 comes first, and then 2. We have a non-including inequality sign, so we have open dots. And then we remember that we have plus, minus, plus. But am I positive or negative? Because my question was greater than 0, which implies positive. But then from the second step onwards, it's less than 0, which means negative. Okay? You always want to use your most recent version of the inequality, which in this case is the negative. Because remember, we had to divide out by -1, which changed the sign of the direction of the inequality sign, and that was actually very important. So it's less than 0. So we are in the negative region. So I connect the 2 dots, and I know that x is going to be sandwiched by -4 and 2. And that is how I approach that question. Thank you very much for listening to my video about basic quadratic equations and inequalities. In my next video, I will tackle the simultaneous equations for this paper, as well as some of the more difficult questions that are found under section question 1 of the Mathematics Paper 1 exams.